Hello, my name is Luis Anthony Ast. I am a professional math tutor with over 29 years of tutoring experience. And you know what that means. I'm old. But I'm still able to help you. The videos you'll be watching all this week are designed to supplement your classroom learning. I do want to point out that throughout the series of videos, I will be displaying what I like to call video flashcards. They're just like regular flashcards you might have made out of index cards, but in video format. Here's an example. Math Tutor. The supreme example of an awesome human being. Yeah, right? No? Okay. In any case, let's get started. Let's say we would like to evaluate the following. 2 plus 3 times 4. Notice that there are two mathematical operations going on, addition and multiplication. Which one should we do first? Should we add 2 plus 3 and then multiply the sum by 4? Or should we first multiply 3 times 4 and then add 2 to that product? Well, to answer that question, we need to learn about order of operations. Here I have displayed our order of operations. Whatever's higher is performed before anything that's lower. So in first place, we have parentheses. For example, 1 plus the quantity 8 minus 3. Since 8 minus 3 is within parentheses, you do that first. Then add 1 to the result. In second place, we have exponents. For example, 3 plus 4 squared. You would square 4 first, then add 3 to it. Multiplications and divisions have the same order of operations. It's a tie. Here we have our original problem that I talked about previously. 2 plus 3 times 4. Well, now we can answer our question. We need to multiply first because multiplication has a higher order of operation than addition. After you multiply 3 times 4, you would then add 2 to that result. Here's an example using division. And notice I have two divisions within the problem. It's a tie. What do we do first? Well, in this case, you go from left to right. So go 20 divided by 10 first, and then divide that by 2. Here's an example using addition. 9 plus 3 minus 1. What do? We also have a tie within additions and subtractions. They have the same order of operations. It's the lowest, but they're the same. So again, perform the operations from left to right. 9 plus 3, get an answer, and then subtract 1. And finally, here's an example using just subtractions. Since again we have a tie, we go from left to right. Go 5 minus 4 first, and then subtract 2. It is very important that you memorize this order of operations. So to help you remember, use the following acronym. Use the first letters of each of the words to create PEMDAS. Now to remember PEMDAS, use the following mnemonic device. Please excuse my dear Aunt Sally. And there she is! Hi, Aunt Sally! Now we're ready to do a couple more examples using PEMDAS. We're given 4 plus 3 squared times 2 minus 10. Which operation should we do first? Well, according to our order of operations, we should square the 3 to get 9. Then, we have additions, multiplications, and subtractions. We perform multiplication next. 9 times 2 is 18. Now we only have addition and subtractions. So you go from left to right. 4 plus 18 is equal to 22. Minus 10, our final answer is 12. This next example is more complicated, but don't let it intimidate you. As long as you follow your steps for order of operations and go step by step, you'll get the right answer. Here we have grouping symbols within grouping symbols. So do what's within the innermost set of grouping symbols first. 7 minus 6 is 1. Within here, you need to square the 2 next. And you get 4. Inside here, you have to now multiply. Negative 4 times 1, you get negative 4. We have the same order of operations, so go from left to right. 3 minus 4 is negative 1. Add 4, you get 3. Now we need to multiply. 2 times 3, you get 6. Negative 5 plus 6 is 1. Factors. Factors are numbers being multiplied together. An example of this is you may be given number 35 and be asked to find the factors of 35. Well, one answer would be 7 and 5, because 7 times 5 is equal to 35. Now you may have also chosen 1 and 35, because when you multiply those two numbers together, you also get 35. So there's more than one answer. Prime number. A prime number is a natural number that has only two distinct factors, the number 1 and itself. Please note that 1 is not prime. You need two distinct factors to be a prime number. 1 just has a single one, itself, 1 times 1. Our first prime number and our only even prime number is 2. 1 times 2 is 2. 3 is also prime. 1 times 3, 3. What about 4? 1 times 4, 4. But wait, 2 times 2 is also 4. So we actually have 3 distinct factors, 1, 2, and 4, that when you multiply them together, you can get an answer of 4. So it's not prime. What about 5? 1 times 5, 5. Multiple. A multiple of a number is the answer you get when you multiply said number by any natural number. Let's do some examples. The multiples of 2 are 2, 4, 6, 8, 10, and it continues forever. For 3, 3, 6, 9, 12, 15, and so on. For 4, 4, 8, 12, 16, 20, etc. For 5, 5, 10, 15, 20, 25, and so on. Least common multiple. The least common multiple, the LCM, of a group of 2 or more numbers is the smallest natural number that is a multiple of all the numbers of a given group. Let's find the LCM of 8 and 12. One method is to just list the multiples of 8 and the multiples of 12 and see where they match. In this case, 24 and 48 are common multiples. They have an infinite number of common multiples, but we want the least common multiple. So that's the one smallest in value. Right here, 24 is our answer. Now this is a rather cumbersome method of finding the LCM. So now let me show you a better way. Now let's find the prime factors of our numbers to find the LCM. To do that, I will use factor trees. To create them, I do the following. Think of two numbers that multiply to give you 8. How about 2 and 4? 2 is prime, so I circle it. 4 is not, so I keep factoring 2 times 2 and circle those. We're done. 12. Think of two numbers that multiply to give you 12. How about 3 and 4? You could have also said 6 and 2. It does not matter. 3 is prime, so I circle it. Keep factoring the 4, and you get 2 times 2. Circle those. Next step is to write down the prime factors of 8. 2 times 2 times 2. Now write down the prime factors of 12 directly below it, if you can. If you cannot, place the extra number to the side. So I wrote down the 2, and then 2. I can't put the 3 here, so I'll put it to the side. Now for the final answer, just imagine you have like arrows pointing down to give you the final answer. So you're going to have 2 times 2 times 2 times 3. Multiply all this together, you get the answer of 24. In this example, I want to find the LCM of 12, 45, and 50. First, create factor trees, then write down the prime factors. Here we have for 12, try to write the prime factors of 45 directly below it. I can't over here, but I can with the 3, and then the extras to the side, 3 and 5. Same thing with 50. I can put something underneath the 2, and then again here with the 5, and then there's an extra 5 at the end. For the final answer, just imagine these columns. So you have 2 times 2 times 3 times 3 times 5 times 5 is equal to 900. The easiest way to multiply fractions is to first try to cross-cancel terms. For example, 3 and 9 have a common factor of 3. 3 divided by 3 is 1. 9 divided by 3 is 3. Let's try it with 8 and 4. They have a common factor of 4. 8 divided by 4 is 2. 4 divided by 4 is 1. Now just multiply our red numbers together. 1 times 2 is 2. 1 times 3 is 3. Our answer is 2/3. The best way to multiply these three fractions together is once again cross-cancel first. 6 and 9 both have a common factor of 3, so I can divide that out. 6 divided by 3 is 2. 9 divided by 3 is 3. 55 and 35 have 5 in common. When you divide them out, you get 11 and 7. Oh, look, 7, 7. They divide out, you get 1 left over. There's a 2 and a 2. I can get rid of those. Now, just multiply through. 1 times 11 times 1 is 11. 1 times 3 times 1 is 3. My answer is 11/3. To divide two fractions, the first step is to switch the places of the numerator and denominator for the second fraction. When you do that, you convert it into multiplication. Now just cross-cancel. 12 and 8 have a 4 in common, so I have 3 on top and 2 on the bottom. Then just multiply straight through. 3 times 3 is 9. 2 times 5 is 10. Our answer is 9/10. It is very easy to either add or subtract fractions as long as they have the same denominators. All you need to do is write down one denominator, which is called the common denominator, and then copy down the numerators again. 1 plus 2 is 3, so the answer is 3/5. Over here, write down the common denominator of 7, and then copy the numerators. 6 minus 1, the answer is 5/7. The problem is when the denominators are different. So before we can do that, let me show you another definition. Least or lowest common denominator. The least or lowest common denominator, the LCD, is the least common multiple, LCM, of the denominators of two or more fractions. It is the smallest number that all the denominators will divide into. To subtract 5/12 minus 3/8, you're going to need the LCD. In this case, it's 24. How did I get that? Well, I found the LCM of 8 and 12. I created my factor trees and wrote down my prime factors and got 24. The LCM is also the LCD. Next, rewrite the fractions and create the spaces with the blank parentheses right here. What times 12 is 24? 12 times 2. Then write that again on top. 2 over 2. 8 times what is 24? 8 times 3. Then again, write down the same number top and bottom. 3 over 3. We have a common denominator of 24. For the numerator, 2 times 5 is 10, minus 3 times 3 is 9. 10 minus 9 is 1. The answer is 1/24. To add a half and a third, you need the LCD of 6, which you can easily find since 2 and 3 are prime numbers. Just multiply them together. Then write your fractions over again, put the parentheses, and then what times 2 is 6? 3. Then copy it top and bottom. What times 3 is 6? 2. Copy it top and bottom. The denominator is 6. The numerator, 3 times 1 is 3, plus 1 times 2 is 2. 3 plus 2 is 5. The answer is 5/6. Algebra. Algebra is the area of mathematics that generalizes the concepts and rules of arithmetic using symbols to represent numbers. The symbols used are called variables and constants. Typically, letters from the English alphabet are used to represent these symbols, but you can also use letters from other alphabets, for example, the Greek alphabet. You can also use different types of shapes, or my favorite, candy-coated chocolate. Variable. A variable is a symbol that can represent a value that is not known, or a symbol that can take on different values from a given set of values. X is the most commonly used variable. Y and Z are also quite popular. Constant. A constant is a number or symbol that represents a specific value. Here's an example of a constant, pi. Its value is actually the most well-known mathematical constant. Here are some more examples of constants. You can use numbers or letters. They can be upper or lowercase. They tend to be from the beginning of the alphabet. Coefficient. A coefficient is a constant that is multiplied to the left of a variable or series of variables. Now let's identify some coefficients. For this first example, 2 is the coefficient of x. For the next one, -5. I don't see a number here, but there is one. It's implied to be 1. Over here, -1. This one's a little sneaky. What do you think it's going to be? It's 1/4. Algebraic expression. An algebraic expression is any combination of variables and constants with mathematical operations: addition, subtraction, multiplication, division, roots, and powers. Neither the equal sign nor inequality symbols are part of an expression. Here are some examples of expressions. They are combinations of variables and constants with mathematical operations. These are not expressions. This one contains an equal sign, this one an inequality symbol. Term. A term is any part of an expression that is separated by plus signs. Let's list the terms of 3x squared plus 5x plus 7. Terms are separated by plus signs. So here's one, there's one, and that's the last one. The terms are 3x squared, 5x, and 7. Now let's list the terms of 8x cubed minus 4x minus 1. Terms are separated by plus signs, so I need to rewrite this expression as follows. 8x cubed plus a negative 4x plus a negative 1. Here are my three separate terms. 8x cubed, negative 4x, and negative 1. When doing word problems in algebra, you may encounter some sort of verbal phrase that you need to convert into some sort of algebraic expression. So let's do that now, starting with addition. Here's some sample phrases that can be converted into an expression that contains addition. The sum of x and 2 translates to x plus 2. 3 more than y is a bit sneaky. You actually put the 3 at the end of the expression, not at the beginning. So you get y plus 3. Z increased by 1 becomes z plus 1. You do need to be careful with phrases that can convert into subtraction because order matters with a subtraction. Here's some examples where the order that the variables are in the phrase become the exact same order in the expression. So the difference of a and b, you just write down a minus b in the same order. 9 is decreased by y, write down 9 minus y. This one's pretty obvious. N minus 3 is n minus 3. With these two phrases, you need to reverse the order of the terms that appear in the phrase. So for example, 10 less than m, you write the 10 at the end of the expression and put the m in the beginning. Switch places. This actually is the #1 mistake students make when converting phrases into expressions. So I really want to emphasize this. When you're given something that has less than, you need to switch places. Am I emphasizing this enough? I hope so. Okay. I'm back. For this last one, 7 is subtracted from b. Just write down b minus 7. Put the 7 at the end. With phrases that become multiplications, I recommend writing down sets of blank parentheses. They could be 2 sets or 3 sets and so on, depending on the wording of the problem. In this case, I have the product of 8 and q. Write down 2 sets of parentheses, fill them in. This is equal to 8q. C multiplied by 4. Write down 2 sets of parentheses, fill them in. This simplifies to 4c. You write down the coefficient before the variable. Whenever I see the word twice, I write down 2 times something. Well, what? Oh, twice x. So it's 2 times x, which is equal to 2x. Now you may have other words besides twice. It could be double, triple, quadruple, and so on. And the very final thing I want to talk about in this lesson is converting phrases into expressions that deal with division. They are very straightforward. Just write them as fractions. For example, the quotient of x and 5 becomes x over 5. Divide 3 by h is 3 over h. And of course, pi divided by 4 is simply pi over 4.